Now let us do the last set of problems, and this is problem 47 to 50. Solve the equations and check your answer. Okay, so let's do number 47 first. Number 47 is 3. So this is number 47. 3e x minus 4. Okay. Plus 5 is equal to 10. Okay. So what are we going to do here? At first it seemed confusing, but if we know what to do, then we could solve this problem. First, we are going to rearrange the numerical values to transpose the numerical value 5 here. So we will have 10 minus 5. And 3ex minus 4 will then be equal to 5. And now we could divide the sides, both of the sides by 3. So leaving me with ex minus 4 is equal to 5 over 3. Right? Okay. Now this is the base of a logarithmic or a natural logarithm, meaning that I could simply put ln here. So I'm going to put ln of e x minus 4. Then I also have ln of 5 over 3 here. Okay? And this cancels out the expressions ln and e, giving me x minus 4 is equal to ln of 5 over 3. Okay? Therefore, my x is equal to, what is my x here? 4 plus ln of 5 over 3. Okay, so this is my answer. Now let me check this answer if this is correct. So let's check the answer. Okay. So let us have the value of x, and that x will be substituted to the original equation. 3e x minus 4 plus 5 is equal to 10. So therefore, we have 3e raised to, our x is 4 plus ln 5 over 3. So 4 plus ln of 5 over 3 minus 4 plus 5, is it equal to, is it equal to 10? Let us see. So in this exponent, okay, we will be having 3e. This one cancels out, right? So e ln of 5 over 3, right? Plus 5. Now is this now equal to 10? It seems so. Like it's getting there. Okay. Now we have 3, and this is, you know, an expression of e and ln, which gives us the value of 5 over 3. So 3 times 5 over 3 plus 5, is it now equal to 10? Okay. This will cancel out. So 5 plus 5, is it equal to 10? The answer is yes. 10 is equal to 10 indeed. Okay, therefore, this value of x that we obtained from this operation that we did is valid. Okay? Let's go to number 48. Number 48 is equal to number 48. Okay, I'm going to change the color. It doesn't seem to fit in. So, okay. For number 48, my equation is 4 minus e 2x minus 3 is equal to 7. So the same process as in number 47. I will have 4 minus 7 is equal to e raised to 2x minus 3. I transform the equation into an expression that shifts the e to the right, so it becomes positive. And now I will go back to the other transformation, just shifting both places, okay, interchanging their places. So 2x minus 3 will be equal to negative 3, okay? And this one will give me, I will just put an e behind put an ln behind e, okay, minus the pen has some problems now. 2x minus 3 will be equal to ln of negative 3. So this one will give me, we could cancel ln and e now. So 2x minus 3 is equal to ln of negative 3. But wait, do we have a value for a negative for ln? So let us try to see that. Ln of negative 3, does it yield a value? So using the calculator, this one gives an error, okay? Meaning that we can't use this, or we can't have a value for this equation, meaning that this has no solution, okay? This equation has no solution. Now let's go to number 49. Our number 49 is 2e raised to 2x plus 5ex minus 3 is equal to 0. Now this is the same case as a while ago when we tried to get the value of x based on a certain given power function for ex, okay? For e, okay, so we have, what did we do a while ago? That e raised to x is equal to u. Then this equation now becomes 2u squared plus 5u minus 3 is equal to 0. Now, is this factorable? Let us see. Can this be factored? Okay. So let's say we have 2u, and we have u here. And what are the factors of negative 3 that makes it positive 5 in the middle? So we have plus 3 and minus 1. Am I correct? So therefore this is factorable. So we're going to deal with it by taking the individual factors, equating them to 0, and getting the values for the u. Okay? So this gives me, for the other factor, u plus 3 is equal to 0. And in here I have u is equal to 1 over 2. And in here I have u is equal to -3. And my e, because u is e raised to x, then e raised to x is equal to -3. Okay? And if we take the natural logarithm of this one, see ln of ex is equal to ln of -3. And this one, the other side, the right side, we have e raised to x is equal to 1/2. Therefore, ln of ex is equal to ln of 1/2. And sadly, for the right sides, we know that ln of -3 does not exist. So this one is undefined or error. It's a math error. Therefore, this is not valid anymore. So we continue with getting the values for x on the right side. Therefore, my x is equal to ln of 1/2. Okay? And that's my answer. Okay, so this is my answer for x. Now let me check this. Is this argument valid? Now let me see. And check, okay? And I have to move this up. So let me check. If my x is ln of 1/2, then that gives me 2e raised to 2 times ln of 1/2 plus 5e raised to ln of 1/2 minus 3, is it equal to 0? Okay. So in this case, we have two e raised to ln of 1/2, and this is raised to 2, okay, plus 5, and this one could be cancelled, so times 1/2 minus 3, is it equal to 0? Okay, so now we have 2 times this one could cancel, so 2 times 1/2 times 2 is just equal to 1, so 2 times 1 plus 5 times 1/2 minus 3, is it equal to 0? Or rather, this part becomes, this is 1/2, so this becomes 1/4, and therefore we have 1/2 plus 5 times 1/2 is minus 3, is it equal to 0? Okay, now it's getting clearer. 1/2 plus 5/2, that's 6/2. So 3 minus 3 is equal to 0. And therefore, our x is equal to ln of 1/2 is a real solution to this equation. Okay? Now we go to the last number. So, okay, let's have the last number. Okay. The equation for the last number 50, is equal to 5 times, so this is number 50, five times 2x minus, or 5 times 2 raised to 2x rather. Okay, let me change this. 5 times 2 raised to 2x minus 3 times 2 raised to x minus 2 is equal to 0. Now the solution of this equation is similar to number 49. So if we want to get an x, let us use some notations. Now let 2 raised to x is equal to w. Okay? Therefore, this equation now becomes 5 times w, or I will first write it into its proper form. So like this, 3 times 2x minus 2 is equal to 0. And this will give us 5 times 2 raised to x is w, so 5w squared minus 3w minus 2 is equal to 0. Now, is this factorable? Now, let us see. Let's say our first factors for these binomial terms are 5w and w. And let's have the factors of negative 2 that makes negative 3 in the middle. So we have 5w and w here, and on the other side we will have negative 1 and positive 2. So we are now precise in the equation. Yes. Okay. Now we take the individual factors. So we take the individual factors and solve for w. Okay? So 5w is equal to, or plus 2 is equal to 0, and w minus 1 is equal to 0. My w here, 5w is equal to negative 2, so my w here is negative 2/5. In this case, on the other hand, we have w is equal to 1. But take note that w is 2 raised to x, so 2 raised to x is equal to negative 2 over 5. And in this case, on the other hand, my 2 raised to x is equal to 1. And to solve for x here, we know that anything raised to 0 is 1, so we could use 2 raised to 0 for this expression. And therefore, my x here is equal to 0, right? So my x here is 0. Okay, how about on the other side? So if I take this as log, so x, this would give me x log of 2. I'm using the common logarithm, is log of negative 2 over 5. And does log negative 2 over 5 exist? Let us see in our calculator. So log of negative 2 over 5, does it exist? It does not exist, so it's an error. Okay, therefore, this cannot be included in the solution sets of our equation. Okay, so it seems that the only solution that we have is x is equal to 0. So let us now check if this equation or this value of x actually could be a solution. So let us see here. So let's check. Okay. all we have to do is to substitute x is equal to 0 to all the x that you can find for number 50. So this gives me 5 times 2 raised to 2 times 0 minus 3 times 2 raised to 0 minus 2, is it equal to 0? So it's questionable. Okay. Now I will proceed. So 5 times 2 raised to 2 times 0, so 2 raised to 0, that's just equal to 1. Minus 3, 2 raised to 0 is just equal to 1. Minus 2, is it equal to 0? It seems so. Okay. Now 5 times 1 is just 5. 3 times 1 is just equal to 3. Minus 2, is it equal to 0? Okay, we're getting there. So 0 is equal to 0, right? Therefore, this serves as the only possible solution, or the only real solution for the equation in number 50. Okay? So that's the end for the problems and problem sets of the properties of logarithm and definitions of logarithm and the change of base property also. Okay, so on the next video we're going to discuss about logarithmic functions. So the definition of logarithmic functions, what are the properties of logarithmic functions, and how to get the particular equations of logarithmic functions. So thank you for watching and have a nice day.